Now what color is it? Clear. So we're going to use the iodine to measure the speed because we can see it. So that's important to have in the abstract, how you're measuring the rate. You're measuring the rate by watching the iodine disappear, and you'll use a stopwatch. So the rate is based on disappearance of iodine. Okay, so that means the rate is going to be equal to negative change in iodine over the change in time. Because remember, what's the negative sign for? Why do we throw a negative sign in? We want the rate to be a positive number or negative number? Positive number. Well, if you're basing the rate on a reactant, is the reactant getting smaller or bigger? Smaller. So it's good. The rate is going to be a negative number, so you want to make it positive. So you throw the negative in there, because the actual delta iodine over delta T is a negative number. Does that make sense? Okay. Now, what type of rate is that going to give me, though? If I measure, how do I find the change of any variable? Final minus the initial, right? So if iodine is limiting, how much iodine is left at the end? 0. So we're basically, the delta iodine is from the beginning of the experiment to the end of the experiment. So what did we say in the notes on Wednesday? What type of rate is that going to give me? Is that going to give me an average rate or instantaneous rate? An average rate. But what type of rates do we need for initial rate method? We need an instantaneous rate when? At the moment of mixing. So how do we get away with using an average rate in an initial rate method problem? There's one important detail in there in the background section. They tell you what the order of the iodine is supposed to be, even though you are going to determine it experimentally. Yeah, what do they say about iodine? It's 0. What's it mean if something is a 0 order reaction? It has no impact, so the average rate is the instantaneous rate all the time, right? There's no difference. In other words, if I were to graph the iodine, here's my iodine, here's time. Okay, it starts off right there. That's my initial iodine. And let's say this is 0 down here. Just give me a straight line all the way to there. So is the slope of this line changing? The slope of this line is the rate. So in a 0 order reaction, there's the slope of this line is independent of what the value of the concentration is. So that's how we get away with it. The iodine is theoretically 0 order, so we can use it as it's a very convenient way of measuring the rate, initial rate, because it's a 0 order and it also has color. We can see the color change. Does that make sense? Now you still have to go through the process of measuring its order. So you still want to manipulate the iodine the same as you will the acetone and the HCl. And in fact, in most cases, because of systemic errors that are part of the procedure, you're not going to get perfect data. So you won't, I mean, a couple of you might get a 0 for that exponent, but you're more likely to get like 0.12 or 0.23 or something like that. You're going to get something, a small exponent close to 0. Most of you won't get exactly 0. Okay. Okay. Now, that was a lot, but a good abstract will have all of those details in it. It's not enough to run the lab with, but so let's run through those again. Primary objective is find the rate law. Secondary is test it. The reactants are acetone, iodine, HCl is a catalyst, and we're basing initial rate on the change of iodine, and that's possible because it's theoretically 0 order. So that's what goes in your abstract. Okay. Okay. P2 is setting up your data table. Notes. How many times are you running each reaction? Twice. Each reaction is being run twice. So you're going to clock each reaction twice, and then take an average of the time. So you'll average your run time. Okay. Now, it does want you to measure temperature as well, even though we're not going to do anything with the temperature. Temperature is not going to be part of the calculations, but it's nice to know what happened to temperature, because you will notice the temperature change a little bit throughout the period. Part of that is because, cram 40 bodies in here with people warming up the room. The air